Here we have a simple Go Hello World application, which just prints Hello World in a loop forever. We have a Docker file that builds a binary from the source file and puts it into a container, and a Kubernetes manifest that creates a pod from this container image. Skaffold has a built-in command, scaffold init, that will generate a scaffold YAML for your code base containing default values to get Skaffold running. Let's run it on the code that we have here. You can see our generated scaffold YAML has one build artifact pointing to our Docker file that builds the image and pushes it to our project's registry. This image is tagged with the git tagging strategy, which uses the latest commit hash as an image tag, though there are several other tagging strategies available. Skaffold also defaults to using the kube control deployer that deploys from our Kubernetes manifest to our existing cluster, though there are several other deployment strategies available as well. As we run Skaffold dev, you can see Skaffold immediately builds the artifact we specified and pushes it to the target registry. It then creates a pod in our cluster using the image we just pushed. By default, Skaffold streams the logs from the pods it creates, so looking at these now, we can see Hello World being logged like we'd expect. One of Skaffold's most exciting features is its file watcher, which watches for changes to one or more local directories on your file system in real time. When Skaffold sees any changes to your code, it will build a new image from source and deploy it to your Kubernetes cluster. Let's change our print statement up and watch how Skaffold reacts. As I change this string to hello Skaffold, we can immediately see Skaffold recognizes that our source file has changed and retriggers a build and deploy. Watching the logs, we can see them switch over in real time to our new print statement as a new pod is created.